Okay, perfect. Silent danger turning on the record.
Thank you, Anne-Rose. So you are free to get started with this room. Thank you.
Thanks. So hi to everybody who chose the GLAM track of the second part of the metadata webinar today. As Judith already said, we have two presenters. And yeah, I would just, let's start with the first one. Maud Henry from the KBR is a metadata librarian. And yeah, we're really excited to hear what you have to tell us.
Thank you, Anne-Rose. Okay, are you able to see my screen?
Yes.
Great. Okay, so good afternoon, everyone. My name is Maud Henry, and I work as a metadata librarian at the Bibliographic Information Agency within KBR, which is the Royal Library of Belgium. I am also involved in IFLA, the International Federation of Library Association. I'm a member of the bibliography section, and I co-chair the working group on universal bibliographic control. And that is a topic which is deeply connected to metadata standards and their global alignment. So in libraries, we have learned one thing: knowledge becomes visible only when it is described and connected. So today I would like to show how library metadata standards support this visibility within the GLAM sector and how they align naturally with the FAIR principles. But I won't go into too much technical details. So together we will explore how those library metadata standards contribute to FAIR in our field and why institutions such as KBR and the international library community play a meaningful role in this broader ecosystem. So before diving into the topic, let me very briefly introduce KBR for those who may not know us very well. So KBR is Belgium's national library. We collect everything published in Belgium. We preserve, manage, and study a vast cultural, historical heritage. But beyond preservation, we also have a mission of access. We support research, we provide information to the public, and we curate cultural experiences. And at the very heart of all this work lies something very essential, which is the metadata. So we produce and manage high quality metadata to describe structure and connect knowledge. Let me start with a simple observation from the library world, and one that actually also applies to research data. So research data does not become visible by itself. It becomes visible because it is described, organized, and made interoperable through shared frameworks. So when information is unstructured, it becomes fragmented. It exists, but it is scattered across systems, formats, and institutions. So it becomes difficult to find, difficult to connect, and difficult to reuse. And this is not just inconvenient, it is a structural barrier to research itself. And this is exactly the problem that library metadata standards were created to address. So FAIR principles tell us what we want to achieve: data that is findable, accessible, interoperable, and reusable. But FAIR does not exactly tell us how to achieve this with our library data. So this is where library standards come in. And in the GLAM domain, libraries have spent decades building models, rules, formats, and vocabularies that align naturally with the FAIR principles. So libraries have developed a shared model for describing information, rules for structuring metadata, formats for exchanging it, vocabularies for ensuring consistency, persistence identifiers for long-term reference, interoperability mechanism for connecting systems. So in other words, library standards provide one of the structures that help achieve the FAIR principles. So standards will allow us to allows interoperability, consistency and quality, efficiency and reuse, and cross-system discoverability. So Here is a diagram of the IFLA standards that we've created with Mathilde Koskat, who is the co-chair of the working group with me, the UBC working group I mentioned earlier. So we've used it in a previous presentation, and I thought it could be useful for this webinar as well. So it shows that IFLA standards and mainly metadata standards in general are not isolated tools. They form a suite designed to work together. So on the top, you have the UBC statement, which I will mention later in my presentation. So it's more like a strategic framework. You have the ICP principles, so the international cataloging principles. They are currently in revision. A new updated version should be available within a couple of months. The IFLA LRM conceptual model, the ISBD standard, which has been used in libraries for decades, the Unimorc format, which is an exchange format, such as Mark 21, the semantic layer, and those are the linked open data versions of the IFLA standards. So each standard plays a different role, but together they create structured, interoperable metadata. So, of course, there are many other standards outside of the IFLA suite. For example, BibFrame, I could mention BibFrame. But I think this is a good example of how the standards are connected to each other, and also those standards are freely accessible on the IFLA website. You can check them online, and you can feel free to use them as well in your library. Okay, so let me focus now on the cataloging standard we use at KBR. One of them, namely RDA, which stands for Resource Description and Access. So as you might have noticed, RDA is not one of the IFLA standards. It's not on the diagram I've just shown, but it is actually based on the IFLA LRM model, which makes it highly interoperable with a lot of metadata standards. So actually, so RDA was created to replace the AACR rules for those who know it. So RDA is often seen as a cataloging code, but I think its real strength is that it is a relational entity-based framework. It describes entities such as work, expressions, manifestation, items, agents, places, time spans, so, and all the relationships between them. So the relational logic, is essential for FAIR because research itself is relational. Publications linked to authors, to institution, to versions, translation, etc. So if metadata does not reflect these relationships, then part of the meaning is lost. Okay, so when we look at FAIR in practice, RDA supports each of the 4 principles in a very concrete way. So its entity-based models and identifiers make resources easier to distinguish and to find. For the accessible principle, I think we could say that RDA helps because its metadata can function independently of any specific format or system. Its alignment with LRM, Mark 21, ISBD, and ONIX, for example, makes it naturally interoperable. And the precision and relational depth of RDA resources descriptions ensure that metadata can be reused in different contexts. Oh, I thought I'd made the change, but it's still okay. So actually, we had an issue with our library management system. Oh yes, this would have correct. Okay. So I had to search for a different description in a different catalog, but I had the time a couple of minutes ago to change the slide. So this is what a bibliographic description from a catalog look like. So this is a catalog following the RDA guidelines, but also this is in Mark 21 as well, exchange format. So for those who know the different fields and tags. So you can notice that we have included the several identifiers and URIs. And for example, in the fields 336 to 8, we are also using a specific RDA vocabulary and coding schemes. Okay, I want also to mention two RDA networks that might be interesting for you. So first of all, EURIC, which is the European RDA interest group. So it is a collaborative network dedicated to the advancement and implementation of the resource description and access standard across Europe. And BRIDGE, which is the Belgian RDA initiative for data governance and exchange. We started this group like a couple of months ago, so we are still very welcome to join this network. Okay, I also wanted to mention UBC and FAIR from my perspective of a NIFLA member, because I thought it's very striking how much FAIR resonates with an old library vision, which is the Universal Bibliographic Control, UBC. And it refers to the concept of achieving global coordination and access to bibliographic and authority metadata through the timely creation and sharing of essential user-oriented bibliographic information. So actually, UBC is based on a simple principle, which is describe once, reuse everywhere. And I think it resonates a lot with the similar idea in the FAIR principle of course, we use the data. So the origins are different. UBC comes from the library science, FAIR comes from research data management, but I think some principles are the same or similar. And what I wanted to say with this slide is, even though there are different frameworks, different approaches, we have different types of expertise, different institutions. We actually want to achieve the same thing, even though it has different names. So to end my presentation, I wanted to highlight the role of national libraries. So as a national library, KBR manages multilingual collections, heterogeneous materials, physical and digital objects, complex metadata ecosystems, and long-term preservation. And to fulfill this mission, we really rely on standards. And KBR, as a national library, plays also a bridging role with the different GLAM institutions of the country, between heritage collection and research communities, between national practices and international standards. And I think this makes national libraries essential partners for FAIR-oriented research. So this is the conclusion of what I already said earlier. But so FAIR principle tell us what good data should look like, and metadata standards tell us how to actually make data fair. Here are some useful links to the toolkit, the RDA toolkit, to the IFLA standards, and to KBR's website. And yeah, actually, I created the ORCID number yesterday, identifier yesterday for this presentation. And here's as well my profile on LinkedIn. So do not hesitate to reach out to me if you have questions, you want to follow up, if you want to exchange ideas. I'll be very happy to hear from you. Thank you very much.
Thanks a lot, and it's really cool that you created the ORCID yesterday. And also, kind of the end of your presentation perfectly summed up the first half hour, the metadata 101. So thanks a lot.
Thank you.
We go on with our second speaker, that is Christina Fischer. And Christina Fischer is conservator at the Leibniz Center for Archaeology. The stage is yours.
Thank you very much. I now try to share my screen, hopefully.
Yeah, worked.
Just a moment. So now you can see my presentation, hopefully.
Yes.
Perfect. Then, good afternoon, everybody. We've just heard how metadata standards works in the library work. And now I would like to take you to a rather different domain, namely the conservation of cultural heritage. Just let me start with a short introduction why conservation data are valuable and underused source of research data. A conservator like myself, we examine objects quite closely, and in doing so, we produce a remarkable variety of data. There are written out observations about the object's condition, photographs documenting the damage and treatment process, measurement data from technical analysis, and records of every material and technique applied. What makes this data so interesting is that it contains a wealth of direct observation about the object itself, things that might not be recorded anywhere else. And that makes it relevant far beyond the conservation workshop. On the slide, I have present some ideas for different domains where conservation data is useful. For example, in provenance and art history, conservation data can reveal hidden signatures, workshop techniques, or layer structures. On the other side, if a conservation measure takes place and a further scientific analysis follows, knowing exactly what material were introduced during a previous treatment is essential, because you need that information to correctly interpret any later analysis and rule out contamination. So just a brief background why we're talking about conservation metadata. Because here's the catch, the problem is that knowledge is right now largely locked away in a very inconsistent forms. On the slides, you can see some examples from my own background and how conservation documentation currently looks in practice. You have handful paper forms, you have detailed textual reports, you have sample worksheets, and you have database entries that looks very different from institution to institution. So every conservator, every workshop, every museum has developed their own way of recording things. That makes the same piece of information might be described in completely different terms in different places or not at all, depending on who writes the record. And the result is that even though there is a lot of conservation data, it's practically impossible to compare it, to combine it, or to search across it. So the knowledge is there, but it's divided and hard to access. And this problem was the foundation of our working group within NFDI for Object. Short background, NFDI for Object is a consortia within the German National Research Data Infrastructure Initiative, and we are focusing on research data in context of material remains of human history. So within this consortia in December 2024, we established a so-called temporary working group, especially dedicated to conservation documentation. So the idea was not to impose a solution from the top down, but to develop something that the conservation community itself would find useful and would actually use. So the process in building the schema was designed to be community-driven from the start. Our now output is what we call a metadata schema for conservation intervention. So it's a structured framework for what have been done in the real world. And it defines which fields a conservation record should contain, how these fields should be labeled, and what kinds of value or vocabularies are appropriate for the documentation. So let me walk you through how we developed it shortly. The first step was to understand what conservators are actually documenting today. As myself as a conservator as well, this was really interesting for me personally. And we conducted a community survey with 240 participants across Germany from different conservation disciplines. So from archaeological conservation, building, monument conservation, etc. And besides other questions in context of conservation, research data management in conservation, we ask them, what information do you record in your conservation documentation? And the results shown here were quite clear. Despite all these different disciplines, the majority of respondents document things like the treatment methods, materials and tools used, and the physical condition and damage patterns of the object. These were what we call primary metadata, so informations about the physical conservation process took place in the workshop. But conservators also document what we call secondary data, so contextual information about the object being treated, such as its material, its title, its type, inventory number, or dating of the object. These are things that are often already exist somewhere in the collection management system, but are also recorded again in the conservation record for context. And this survey gave us an empirically grounded list of what the community considers important to document. And that was our starting point for building the schema. So with the content list in hand, the second step was to turn it into a proper schema. And we compiled all the identified fields into a structured table using a widely adopted standard called SKOS, the Simple Knowledge Organization System. So SKOS gave us a few, a schema for modeling our knowledge, our metadata. And each metadata element were recorded not just by name, but with a set of properties. We had preferred label in both German and English, alternative labels like synonyms, a definition, a level of obligation, etc. And we also started to align our elements with existing standards and for museums and collection management. So we wanted to make sure we weren't reinventing the wheel, but that our schema could connect to what already exists. Now, having agreed on the element name is one thing, but language is very complex. So two conservators might use completely different terms to describe the same entity. One calls it condition assessment, and the other one calls it condition investigation. Especially in German, there are a few terms describing exact same process. So these are all the same concept, but if you're searching across databases, you miss connections. So to solve this problem, we created the metadata thesaurus. It's a shared vocabulary that acts as a translation layer between different terminologies of the metadata elements. So the thesaurus is based on SKOS RDF. This is a machine-readable language, and each concept gets a stable, unique identifier. So this is a web address that acts as reference point. This means that even if two conservators use different labels to document what they have done in their own database, they can all point to the same underlying concept in our thesaurus, and the data system can recognize that these metadata refer to the same thing. Here you can see a screenshot of the thesaurus at the moment. It's published as open access GitHub page and is searchable and displays all the concept both in German and English. And on the right side, you can see for each concept, in this example, condition assessment, you see the identifier, the definition and labels, etc. So this gives every institution, every database, every conservator a common reference point without forcing anyone to change their existing software or terminology. And in addition, to make the schema more tangible, not just like a spreadsheet, but something that people can actually test, we built a simulation of what a database input form could look like. You could see it here. It's structured from collapsible sections corresponding to the top level categories of our schema: condition assessment, investigation, sampling, conservation concept, and so on. And each section can be expanded to reveal its fields. The mockup page is directly linked to our thesaurus, so you can read the definition of each metadata element. And this mockup page provided a useful communication tool in the development process, because conservators could try out the schema with their own data and provide valuable feedback to us. On the slide, you see a QR code, so you can try out the schema yourself if you'd like. Of course, a schema developed within a group needs to be tested and refined by the broader community it's meant to serve. So after the draft phase, we presented the schema to the broader conservation community, and we asked not just, does this look right, but more specifically, is the level of obligation appropriate? Is this field repeatable? Should this value be a controlled term, or do you need a free text here? And should this field be mandatory, recommended, or optional? And I must say it's an iterative process. So the draft, we present, we collect the feedback, we revise, and this is ongoing. The schema is a living document, but at the moment we have a first represent step towards a shared and community-owned standard. So let me show you a quick insight into the actual shape of this schema at its current stand. At the highest level, we kept the separation between primary data, so data which is generated directly during the conservation process, and secondary data as contextual information about the object itself. On the primary side, the main categories are condition assessment, conservation concept, risk potential, preventive conservation, and of course, the administrative metadata about the records. And of these concepts, conservation concept and the administrative metadata are marked as mandatory, so they must always be present. On the secondary side, we have object identification and object description, which collect the basic information about the artifact. Let me zoom into one branch and show you how it works on the field level. I've chosen conservation concept because it's the core of the schema. Under conservation concept, you have three sub-elements. So the reason for the conservation intervention, the conservation objective, and then one or more interventions. As you can see, intervention is so-called conditional mandatory element because the conservation measure took place, then you must document it. But in real life, it happens that you just plan to do this, so you can document the other ones and don't need to save the intervention just after it has been conducted. Sorry, I got an email and I was disrupted. So each intervention in turn contains a set of fields. So the responsible conservation facility, the intervention identifier, and the responsible person, the conservator, the start and end date, and so on. And then, of course, the heart of the conservation documentation is the treatment it took place, and there you can document the method and the materials and tools used. So you can see this is a quite precise picture of what happened, when, by whom, and with what. And at the moment, we're focusing on the content side of the schema, and we wanted to publish it mid-year this year, hopefully. And the next step will then be to build a connection to established exchange formats. We already heard about Lido, the lightweight information describing objects, as generic standard for metadata in the cultural heritage field. And Lido is the XML-based format, which is highly established across museums and heritage institutions. On the right side of the slide, you can see a small snippet what it could look like if our schema is expressed at Lido XML. So a conservation intervention represented as a Lido event with the element type directly linked to our thesaurus via the identifier. And this is how our schema moves from being a content definition to being truly interoperable, readable and shareable across different institutions and systems. And this brings me to my last slide and the bigger picture. We already heard about this in the former presentation, because why all this effort? The goal is interoperability. That means the ability to integrate conservation data into the broader knowledge network. And if our schema is aligned with Lido, conservation records can be published as structured data in research repositories and potentially fed into a knowledge graph system, and then be linked across disciplines and institutions. That means a conservation record from one museum could be linked to archaeological excavation data, to art historical analysis, to scientific measurement results from another institute. And through this, it enables research questions that none of these data sources could answer alone. And if they are queried together, the real power of structured machine-readable data is that it reveals patterns across many objects and many data sets that would be completely invisible if you only ever look at one data set at a time. And that is ultimately where we are working towards, but I must say this all is still work in progress, and we actively welcome feedback and participation from the community. And with this, I thank you very much for your attention.
Yeah, thanks a lot for the super interesting insight into this community-driven approach. It's really cool to see that people are putting in the effort to get to those standards. So for the next part, we have actually so the STEM part is a little late. Both of our presentations were so perfectly on time that we can now, we apparently will regroup at 3:05 for the Q&A. Which means that we can now, everybody can get their coffee if they want to, and we meet back in the main room in 5 minutes. Yeah, thanks a lot.
Thanks, Christina and Maud. I appreciate your timeliness, and I also appreciate the quality of your presentations. I'm looking forward to the Q&A, and see you, I guess, in 5 minutes, if that's okay for you.